Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 5th. Looking at significant wave heights for the South Pacific Ocean, we see an area of seas to 36 feet southeast of New Zealand, generating swell, with primary swell ahead of that already in the water. Things are looking better. Let's get into the details. Looking at jet stream level winds, these winds up about 30,000 feet, they help support the formation of gales and help direct a gale's track once it does form. We're looking for a trough, and currently we see one. Pretty obvious too. That is upper level winds, fairly strong. What is this, about 130 knots, pushing to the northeast here, forming a little bit of bow in the jet. That helps create clockwise circulation in the southern hemisphere, which is the sign of low pressure. And also down at the ocean surface, this generates winds. Winds generate seas. Seas, when they radiate away from the fetch area, generate swell, and swell, of course, generates surf. So we have one trough here, but then we have a big ridge also over the southeast Pacific, creating high pressure aloft and not supporting gale development there. But still, this area right here, southeast of New Zealand, as we saw on the significant wave height chart, is currently generating seas. Let's put this into motion. That trough, if anything, is supposed to build a little bit into Monday and then lose a little bit of energy, but then get a second wind with yet, what is this? 170 knot winds building into it on Tuesday, yet reinforcing that trough into Wednesday, and then things start petering out on Thursday. As we get into Friday, then we fall into a zonal flow, almost a ridge pushing south under New Zealand. That should squash gale development, at least for a little bit. But then we roll this out, and we see another area of wind starting to develop, Saturday into Sunday, and things almost start looking like maybe some sort of a trough could develop here. But also notice the northern branch of the jet stream, which was way up here. In fact, we'll just go take right back to the beginning. See, it's been running here right around 25 south across this line for a week now, but now a week out, it's supposed to dip south. If the two streams of the jet stream can merge and actually form a trough, we could have yet another storm. Next, we take a look at surface level pressure, surface level winds, and we see a pretty deep low here. What's that, about 948, maybe even 944 millibars southeast of New Zealand. High pressure over New Zealand. This is the classic post-El Nino setup. You get sort of high pressure here, low pressure tracks under it. The low pressure forms a gradient, that is a lot of isobars stacked together, creating southwest winds that generate swell aimed well up at the U.S. West Coast, California in particular, but also down into Mexico, and of course all the major swell targets here in the Americas. Anyway, so we see, 35, 40 knot winds, pretty good size fetch, a little patch of 45 knot winds there. Gale force winds aimed to the northeast, generating the seas that we saw previously. That continues. Notice we actually get this sort of secondary fetch developing, two patches of 40 knot winds on Monday, and then they kind of fade out a little bit. Get a pretty strong system here, but notice 45, 50 knot winds all pushing due south to Antarctica. High pressure pushes east from New Zealand on Tuesday, and another fetch develops Tuesday night. 40 knot winds aimed well to the northeast, building to 45 and 50 knot winds. That would make that storm category Wednesday morning. And then even 55 knot winds in little patches here Wednesday night into almost Thursday morning. And notice right in here, the fetch is aimed almost due to the north. That would be very good, especially towards maybe even some sideband swell for Hawaii, but mainly for California. So California is right around 120 east. So this would be like a rather more south-angled swell compared to the previous energy that we've been seeing forecast. But still, solid south winds, and then that starts fading out into Friday. The short of it, though, and then high pressure sort of takes over. The storm track starts petering out. Let's go take a look at this, roll this out. But though, here we go, another gale forecast with 45 knot winds on Saturday. But actually, this looks a little bit better than what we saw previous runs of the model, but not pushing to the northeast, just more straight east, if anything, or even a tinge to the southeast. Roll that out, and then another high pressure sets up over New Zealand on almost Monday, and wind energy pushing under that, but nothing obvious in terms of swell production. Let's go take a look at the wave models. So here we go, significant wave heights for the South Pacific Ocean. But we're going to go back in time a little bit. Wednesday night, Pacific time, and notice seas start developing south of New Zealand, 26-foot seas, and those build to 28-foot about midday Thursday into Thursday evening. Now this area fetch here, and the winds were in the 40-knot range. This is not so much a swell producer, though certainly Tahiti will get swell from it, and Hawaii will get swell from it. But what this system served to do was rough up the ocean surface so that when more fetch comes over it, it gets traction on the already roughed up seas and can generate yet higher seas and much quicker, even from the same amount of wind. And sure enough, here we come on Friday morning, 30-foot seas, 47-knot winds, and that quickly built in, whoops, there we go, to right about there. That was the peak of it, was at about 35-foot seas, and that's a stretch, 34-foot seas with 45-knot winds in that area on Friday. So that is what will result in swell number 1, again aimed at, of course, Tahiti, of course, Hawaii, and the U.S. West Coast, and all the Americas, and pushing a bit to the northeast. Then we got into Saturday, and another fetch patched over that exact same area, generating 34-foot seas, but the fetch kind of fragmented and weirded out, but then it peaked out right about here, let's say, Sunday morning, 36-foot seas in one small patch, 43-knot winds. So this is swell number 2, and that is already in the water. So there's a primer swell, swell number 1, swell number 2 here, and now let's go, and then here we are at the current situation, still basically the same. Let's go take a look at the future. So here we go, current picture. We roll this out. This system sort of decays, falls apart, but then it tries to regroup a bit to the east of its previous position on, let's say, Wednesday morning. What is that, 34-foot seas? And again, remember, the fetch here is aimed almost due north. There's a little bit of a northeast tilt to it. 34-foot seas, building to, where do we go here? We're in the 40, 42-foot range, and then up to 46 or almost 47 feet late Wednesday night forecast. Holding up to 48 feet on Thursday morning. But again, now this is theoretically pushing pretty well to the north, though this chart suggests maybe more of a northeast push. The result, still, swell for California at a minimum. Actually, let's go back. Let's see relative to Hawaii. So Hawaii's at 155, so certainly some energy pushing up into Hawaii, but most of this energy looks like it's going to be target California, Mexico, and then down later in its life, down towards Central America and Peru, and certainly Chile will see some out of it too. So that's swell number 3. Plus the primer swell that preceded it. So a lot going on there. Then we roll this out. Not such a clear pattern thereafter with no continuous fetch, but a lot of energy trying to make it east under Australia. So certainly swell looks to be on the way. And for a little bit of confirmation regarding the current system, this is as of 06Z Sunday. The Jason 2 satellite made a good pass pretty close to the core of this system. Per the WaveWatch wave model, seas were probably projected about in the 31-foot range. A 15 average reading measurement in this area was 32.9 feet, so a little bit higher than what the models were projecting, and a single measurement in this range was 37 feet, so certainly the models are doing a good job of projecting this system, if not undercalling it a little bit. And we're going to do a quick look back at the primer gale. This was on last Thursday evening. We got a pretty decent pass here. The Jason 2 satellite is projecting, was at 20, 22, 24 foot, maybe 20, 25. Is that right? 20, 22, 24. Yep. 25-foot seas roughly in this area. And the model, higher seas were forecast back here. We couldn't get a really good confirmation. We were just trying to read the numbers. That looks about on track, but in the 24-foot range. So the model did a good job on that one. And then the second storm on Friday night had projected 34-foot seas. The Jason 2 satellite confirmed seas at 34 feet. That was a 15 reading average, so right on track with a single reading to 39 feet. So that was pretty good. And then if you look ahead, then we go out to Saturday night, 11 p.m. Seas here were projected at about 32 feet, and the 15 reading average was 31.7 with a singular reading to 35.7. So again, pretty much right on track. So the short of it is a primer gale, swell number 1, swell number 2, in the water, pushing to the northeast, with yet a stronger system forecast midweek or so, with up to 48-foot seas over small area, but from a more south angle. These storms would be more southwest, depending on your break, whether it be prefers south angled swells or southwest. A little bit of variety from all these systems. Next, let's take a look long term, see what's going on with La Nina. But really, that's not so much what we're interested in. It's the hangover of El Nino, still going on, still clearly affecting the storm track, exactly as expected. It is not unusual to have the southern hemisphere increase production the year or the summer following an El Nino, and that appears to be what's going on, at least for now. Let's get into the details. First up, a quick inspection of the Kelvin wave generation area. That is this area between about 135 east and the date line, a little bit east of there, 170 or so, and just 5 degrees north or south of the equator. Clearly we see east winds here, no west winds, no potential for generating Kelvin waves, but even if we did have west winds, there's no warm water to produce a Kelvin wave anyway. Still, we're looking for hangover effects of El Nino. Anomaly-wise, we see pretty much a neutral wind pattern. Notice there's a little bit of west winds right here around 120. We'll talk about that in a little bit. Typically, the way El Nino works is in its early stages, it produces west winds out here near New Guinea, or at least westerly anomalies. And then over time, right about at the peak of El Nino in the December time frame of the peak of El Nino, most of those winds are right around the dateline area. And then as you get into the summer following El Nino, the westerly anomalies work their way off to the east and eventually collapse somewhere just west of the Galapagos. And that's exactly what it looks like things are doing now. Here's another way to look at it. The Kelvin wave generation area is roughly right about here. Here's the dateline right here. So it runs from about here to here. And so this is a look back in time in May, and you see blues are easterly anomalies. We've had easterly anomalies for a while now, almost the whole month of May. A little bit of the oranges and yellows are weak westerly anomalies. This is up at 4,500 feet, the 850 millibar level. But nothing significant. But notice westerly winds solid at 120 west. Not that it does anything for El Nino. It's just something to look at. Maybe some sort of a El Nino hangover, as we suggest, as westerly winds slowly work their way, or westerly anomalies work their way to the east. But nothing of any interest. And a week out, even the westerly anomalies in the Kelvin wave generation area are to die out. We look for the presence of the active phase of the MJO. The MJO is a pattern that runs 3 to 4 weeks on, 3 to 4 weeks off. That is in an active state and then oscillating to an inactive state. And it typically travels on the equator from the West Pacific to the East Pacific. It actually goes the whole way around the planet. The blues is what we're looking for here. That'd be the presence of more precipitation than normal and westerly winds, the active phase of the MJO. The statistic model suggests basically no MJO signal for the next 2 weeks. The dynamic model here suggests perhaps the inactive phase of the MJO setting up over the Kelvin wave generation area a week out and holding for an additional week. But there's a bit of disagreement among these models. Phase diagrams are another way to look at where the active phase of the MJO is and where it's going to be moving to. This center, imagine you're looking down on the North Pole of the planet, of course, and the MJO travels from west to east, from the Indian Ocean, over the maritime continent, over the dateline into the West Pacific, over the Americas, over the Atlantic and Africa, and back into the Indian Ocean. Right here is where the active phase of the MJO is, and if it's within this circle, that means it's extremely weak. And the forecast is for, at some point, maybe the active phase to reemerge 2 weeks out in the Indian Ocean. The GEFS, that's the GFS ensemble model, is forecasting basically the same thing, but a stronger version of the active phase in the Indian Ocean out, maybe 9 or 10 days or so. But no strong MJO signal forecast, pretty consistent with the other models. And the CFS model suggests, now we've seen this chart before, again, the Kelvin wave generation area, 180 here, so basically in this area, but this chart goes past history at the bottom, going to future history here. Of course, strong westerly wind burst in February, a far weaker one in April. Currently, here's where we are, very weak westerly anomalies over the Kelvin wave generation area, a little bit stronger south of California on the equator. We'll overlay the MJO here. This suggests some sort of a weak active MJO is in play, but weak is the operative word here. And you look as you get into about mid-June, that dies out. Westerly anomalies die out, and then you get this just sort of a weak, incoherent pattern, but building easterly anomalies, once we get into August or so. The interesting part about this chart is, here we go, the black line is El Nino. They call it the low-pass filter, and it really shows you where El Nino is and peaking at in February. It was already a bit east of the date line. And as you work your way into September, what little is left is supposed to be south of California on the equator, and only one contour here, so all but gone. The peak of it was back in the January time frame. So El Nino pretty much all gone by the September time frame. One could almost surmise this dotted line here is the onset of true La Nina. We'll see how that plays out. Next, we take a look at subsurface ocean temperatures. West Pacific here, East Pacific here. We're looking for, during El Nino, you have lots of warm water here. Oh, this is down at depth too, 100 meters, 200 meters. We see warm water is actually retracting off to the west, as would be expected during a normal year or a La Nina year. A lot of this warm water, this line here, the 28-degree isotherm, actually at one point had worked itself the whole way into Ecuador. It has since retreated dramatically to about 159. Appears to be holding there steady at the moment. Now, also during El Nino, we had warm water working in pools or pockets, smaller than this one, but essentially Kelvin waves, and a large warm pool here that is all gone. Any warm water at the surface or warmer than normal water is gone, pushed back to the west. We now have basically a river of cooler than normal water working its way off to the east. The interesting part about this is, just like our previous El Nino was westward displaced, this developing La Nina appears to be a little bit westward displaced too. Normally if we had a strong El Nino, this cool water would be erupting right along Ecuador and the Galapagos. Instead, it's out here somewhere, was at 140, so just east of Hawaii, down on the equator. This seems to be the eruption point. Maybe that suggests that we'll have a weaker than normal La Nina response, which would be a good thing. Seeing a little bit of warm water off Ecuador here is not a bad situation. But you go look at the high-res chart here, basically the same chart, just different data sources, and it suggests that cool water is in fact working itself the whole way to Ecuador, though the main eruption point, just as we saw in the previous image, is right here between 140, 150 west, so south of Hawaii somewhere. And the last little pocket of warmer than normal waters associated with El Nino, which we're all over here, are getting blown off to the east, dissipating by trades, and we're slowly restarting to get a more normal looking ocean, subsurface ocean configuration. Just for fun, upper ocean heat anomalies, you can see the transition clearly. This was El Nino during July, August, September, October, November, December. The large Kelvin wave was this, probably number 2, 3, 4, and 5, working their way from the West Pacific to the East Pacific. Now we see nothing but cooler than normal water at depth in the Pacific Ocean and working their way off to the east. This is classic La Nina. Next, let's take a look at ocean surface temperatures. This is actually deviations from normal anomalies. Here we go, right along here, Peru. We see cooler than normal water developing. That is because of upwelling along the coast here, and that continues right up to Ecuador, then moving off the Galapagos and spreading west to a point south of Hawaii, which would be down around here, and pretty much going 3 degrees north and south of the equator. The 5-degree mark is right along in here and here. So there's still pockets of warm water there, but there's also equal pockets of cool water, netting out probably about a neutral balance of water temperature in the main Nino 3.4 region, which runs from about 120 west out to about 170. Certainly no signs of El Nino, certainly a clearer signal of La Nina. Looking here at the differences or temperature trend for the past 7 days, we see these pockets of warm water, but we also clearly see these pockets of cooler water. Also notice the trend is cooler temperatures, mirror image sort of what's going on off of Ecuador, also off of Africa. That actually, so the way we've seen this happen is the signal will show up first off Africa and then grow along the in the eastern Pacific. This little signal here suggests to us that temperatures might get a little bit cooler or continue to cool stronger in the Pacific over the next week or two. And then the broader view here, of course, shows cooler than normal temperatures in the heart of the equator. Classic La Nina sort of configuration. But notice a lot of warm water north and south, hangover from El Nino. Also notice this cool water here. This is classic PDO, active phase of the PDO. The active phase of the PDO, we've talked about this in the past, is a good sign in that it suggests a trend more favorable to El Nino and storm production in the northern hemisphere during winter months. We've gone through about a 5 or 6 year stretch. Really, it's been since 98. We've had periods of pretty active stuff going on, but the past 5 years have just been a very weak weather pattern in the Pacific in terms of storm production, other than this past winter, which is influenced by El Nino. The thought is, if the active phase of the PDO or the warm phase of the PDO is starting to set up, then that should actually help promote storm production and actually precipitation into California in the years to come. Way too early to say that we're in the active state, but it's been almost 2 years. The numbers are trending that way since January of 2014. If we can go about another year, then, into, let's say January 2017 or so, maybe April 2017, then one could start pretty firmly declaring that we have moved into the active state. Finally, we want to look at the effect of El Nino on the atmosphere or whatever is going on. So we look at the Southern Oscillation Index, one measure, differences in pressure between Darwin, Australia, and Tahiti. What we want to see is negative numbers on the daily index here. We don't see that. We see, if anything, positive numbers. So a medium run of positive numbers suggests the inactive phase of the MJO. You look at the 30-day running average, and if it's negative, then you could say certainly we're in the active state of the MJO. Clearly that's not the case. We're positive here at 3.22, so at least a inactive MJO going on. Then you look at the 90-day running average to look for signs of El Nino, and it was pretty negative here, minus 14.99 on May 3rd, and since then it has continued to get more closer and closer to a neutral state, currently at minus 6.63. Suggesting that El Nino is dying out. The ESPI index, which is basically the same as the Southern Oscillation Index, but it measures differences in precipitation north of Darwin and then over the ENSO or El Nino area. The index had been positive for 2 years. It is now dropping negative, suggesting that La Nina is taking hold and less precipitation, or at least rainfall anomalies, are turning drier over the Nino regions, another signal of La Nina. Oh, and one last look here at sea surface temperature anomalies, the index. This is the area right there between the Galapagos and Ecuador. It's actually bumped up a little bit lately, and we saw that on the subsurface charts too. Like there's this little bubble of warm water holding there. Nothing significant. It's up a degree. We'll see if it holds, but that suggests, at least here since even April, that this La Nina thing that's going on appears to be a little bit westward displaced. You would think the core of it would be right here in the Nino 1.2 region, but that is not the case. And sea surface temperature anomalies in the Nino 3.4 region, the main area used for measuring El Nino, are now dipping negative, minus 0.331, about, still pretty close to neutral, but we expect these numbers to continue to slide negative as La Nina gets more entrenched. Notice we were up in the plus 2 degree range, clear sign of a strong El Nino. And the CFS V2 forecast for Nino 3.4 region sea surface temperatures. Here we are currently in the June time frame, and temperatures are, as expected, dipping below normal. This model suggests by July we'll be about as far down as we're going to go, at about minus 0.7 or minus 0.75, holding there into the fall, maybe dipping down to minus 1.1 right around December, but then quickly bouncing out of that. Of course, it's kind of hard to believe any model that far out in the future, but this model's been holding consistently with this sort of profile. It actually had temperatures much more negative, down to about 1.5 or even more at one point, but it has rebounded, kind of warmed up. I mean, this is still clearly a La Nina pattern, but not a super strong one. And the consensus of just all the other models, dynamic and statistic models, are all somewhere clustered around a minus 0.8 or 0.7 peak anomaly in the December timeframe. So this is maybe almost a worst case scenario, which wouldn't be the end of the world. What we're looking for is any sign that the PDO is turning active, and if this La Nina turns out to be not so strong and short-lived, that would be another piece of evidence suggesting that the PDO is in fact turning positive. So for now, pretty good surf situation setting up considering it's summer. A primer swell, 2 other swells in the water, and possibly a third swell forecast, suggesting at least a week of southern hemi swell, not with huge size, but considering that the swells are so close together, there should be a fair amount of consistency and all from pretty much the same direction. So something to look forward to starting, about a week, starting late this coming weekend. Certainly the week after should have lots of surf. Long term, El Nino fading out, La Nina trying to get a foothold. We'll see how strong it really gets, and even longer still, possibly the PDO turning positive, but that's another year away. But overall, things could be a lot worse than the way they are now. So take whatever swell you can get, make the most of it, be happy, and we'll do this again next week. Same time, same channel. Thanks for watching.